Year 13 short revision video number 10. So instantly we can see we have a mechanics question. We have two blocks at rest connected by a light inextensible string passing over a smooth pulley. A has a mass of 4.7 kilograms. So instantly I'm going to draw in the weight of A, which is 4.7 g, resting on a smooth plane inclined at 60 degrees to the horizontal. Let's put in the normal reaction on A, which I'm going to call RA. And there's obviously going to be a tension in the string like that. B has a mass of 4 kilograms, so let's draw in the weight of B, which is 4g. And there'll be a reaction force of the slope on B, which we'll call RB. And then it's one single light inextensible string over a smooth pulley, so tension constant throughout the string. There we are. And B is on the point of sliding up the plane. So the system is at rest, which means everything is in equilibrium. So that means that forces are indeed balanced. Now, if B is on the point of sliding up the plane, we know that B is on a rough plane, which means there must be a frictional force which opposes the motion of B, or the intended motion of B. So if B is about to slide up the plane, because essentially the weight of A is pulling it up the slope, or trying to pull it up the slope, there is a frictional force acting on B down the slope like that. So we always need to make sure we start off with a really clear diagram. I'm also going to draw in the components of the weight of A, like that, and the components perpendicular and parallel to the plane for the weight of B as well. So, part 1, show that the tension in the string is 39.9 newtons, correct to 3 significant figures. Now, if we look at block B, there are two unknown forces, tension and friction, acting. So it's going to be very difficult for us to really find out more about block B. So what we need to do is focus on block A. And we know forces are balanced. So what I'm going to do is look at forces that are parallel to the slope acting on block A. So up the slope, we have the tension. And that is balanced by this component of the weight acting down the plane. Now, we know that this angle here is the same as the angle of the slope, so that's 60 degrees. Look at this component going down in that direction there, opposing the tension. It's opposite the angle, so it's a sine component, that is 4.7g sine 60. So T is equal to 4.7g sine 60, and we can evaluate that. It's equal to 39.889 ... newtons, so we can say 39.9 newtons to 3 SF, or 40 newtons to 2 SF. Now, for part 2, we've got to find the value of the frictional force and the normal reaction acting on block B. So let's start with block B, and let's look at forces which are perpendicular to the slope, like that. Now, what do we have perpendicular to the slope? We have RB, and RB is balanced by this component of the weight. Now, again, this angle here will always be the angle of the slope, so that's 25 degrees, and this component that's perpendicular to the slope is a cos component. Look at it, it's adjacent to that 25 degrees, so that is 4g cos 25. So RB must be equal to 4g cos 25, so that gives us a value of 35.527 ... or 35.5 newtons to 3 significant figures. And we're then left with finding the tension acting on block B. So we now need to look at forces acting on B which are parallel to the slope. Now, going up the slope, we have the tension. That's the only force or component going up the slope. And that is going to be balanced by the friction, which is going down the slope, and also this component, just highlighting this in orange here, of the weight, which is opposite the 25 degree angle, so that is 4g sine 25. So friction and 4g sine 25 both go down the plane, but t goes up the plane. Now we know that t is 39.889, etc. So we can use this to calculate the value of the friction, and it comes to a value of 23.322 ... or 23.3 newtons to 3 SF.